Okay, welcome everyone to the second session today. That's everyone, great. The talk is going to be on persistence, the official library, and Hugo is going to be our speaker. Please welcome him. Thank you.
Oh, sorry, no worries. Hi, good morning everybody. My name is Hugo. I'm an independent Android developer at Little Robots. I'm also a GDE for Android. And today I'm going to talk about Room, and I know the program said the official persistence library, but I thought like blessed was maybe a better word for it. Anyways, before I go into Room, the library that was released at Google I/O, let's first take a quick look at the state of persistence on Android, what the platform gives you basically. So basically there are two options for persistence, for storing stuff. You have your shared preferences class, which is only meant for small amounts of data, key value, strings, ints, that kind of simple storage. And if you want to store anything more larger or also more complex, then you often go down to the SQLite layer that Android also provides. The problem or the challenge with SQLite on Android is that its API is kind of low level, kind of not easy to work with, and there's a lot of ceremony that you need to do when you want to store some stuff in SQLite. So over the years, persistence frameworks have popped up to solve this problem, and initially those were ports coming from more server-like environments. ORM Lite is one of the early ones, and over the years, a lot of these frameworks have popped up. So when looking at these persistence frameworks, there are actually two flavors. There are persistence frameworks that build on the SQLite platform support, and there are frameworks that basically don't use any of that. Realm, Objectbox, Couchbase, that kind of products are basically using their own storage solution, and they do not use SQLite. Some examples here: SQLite is pretty popular nowadays. GreenDAO is one of the early ones. dbFlow, and I could not mention my own cupboard. Cupboard is something that I wrote a couple of years ago because, well, the things that were around I didn't quite like them. But what these have in common that they use SQLite underneath in various shapes or forms to help you to write basically correct database code. Because when writing SQL statements, it's easier to make mistakes. There are different ways to approach writing correct SQL, basically. So if you look at SQLite, everything is SQL. So you write your SQL code, you write your table definitions, you write your query definitions, and SQLite will go out and generate the schemas and, well, not the schemas, your models actually, your Java classes, which is very powerful, but also requires you to know a lot about SQL, the language. And they solve the problem of making typos and that kind of stuff in the tooling. So the tooling will check if your SQL is correct. At the other end of the spectrum is, as an example, my cupboard library, where I, on purpose, made sure that I used less features of SQL, so it's less powerful in that sense. But it also means that you're using less SQL. So there's almost no SQL in cupboard. You can use SQL if you want to, but you don't have to. If you look at other libraries like GreenDAO, they abstract SQL. So they have their query builders. They have their own abstractions upon SQLite to make sure that you are writing type-safe SQL code, basically. And let's say that Room is somewhere in between here. Room does not help you with creating tables and that kind of stuff. But when it comes to actually fetching data, querying data, where SQL is great at, that's all written in SQL. So you do need to know a bit of SQL for when you are going to use Room. So let's some key points. Room is part of the Architecture Components initiative that Google launched at I/O. It consists of an opinionated guide on how to write Android apps, and it also has a couple of components that allow you to implement that architecture that they propose. And Room is one of those components. Room does not support storing entity relations by design, which means you can't really expect Room to take your object model, your entire object model, and throw it in the database and without any effort. It simply does not support that kind of stuff. And that does it for some good reasons. It's hard to get that performant. There are some issues when, for example, if you have something like lazy loading and then you're on the UI thread and you're fetching something, you're basically doing I/O work on the main thread, and that gives a lot of problems. So Room, they just decided not to do that. I think that's a good decision. Like I mentioned, they use SQL for all the database interaction. So there are no query extractions. The current version is actually, as of this morning, beta 2. So they're still in beta. And this morning I woke up, saw my Twitter stream, and realized I needed to update my slides. So I did. And it's created by Google, which is also means that there is a little bit more development power behind it, maybe. Also, easier to introduce in your project in some cases. For me as a freelancer, it's easier to tell, well, this is from Google, so let's use this in the products, because when I'm gone on these projects, people after me, other developers, will probably be familiar with this particular tool. So that might be beneficial. And you can imagine that in terms of tooling, Google controls the Android Studio as well, so you might have some tighter integrations when it comes to tooling as well. So, getting started with Room is pretty easy. There are basically two things that you need to do. Of course, there are dependencies. So for Room, there are actually two. There's this runtime dependency, which is basically a bunch of annotations, and there's an annotation processor. So Room does most of the work in the annotation processor, and this is also the place where they validate your SQL. So they tackle the problem of making typos in your SQL code by using tooling, and also by using this compiler. Usually when you're using Room, you also want to add another architecture component, in particular the live data component, and that requires you to be on a fairly recent version of support library. And then there are two dependencies again for lifecycle components. So you have your runtime and your compiler again. There's one other thing that you need to configure for Room, which is the place where Room needs to export its schemas. So when you define your object model for Room, Room also has the ability to export the schema of that. And actually, this is turned on by default. So if you don't specify this option to the annotation processor, then at compile time you get an error that Room doesn't know where to export these things. So in practice, this is required because those schemas are very useful also when writing migrations and other types of if you want to take a peek at the database basically, then you need these schemas. And they recommend that you check in the schemas so that over time, as your app evolves, you have this collection of schemas for your databases in time. So this is configuration for Java code. For Kotlin code, it's actually pretty similar. Instead of annotation processor, we use capt, so we apply the capt plugin. And capt, of course, you also need to configure that to set the schema location. Otherwise, it's just the same setup. You just replace annotation processor with capt. And if you're still using Android APT, stop it. Don't file bugs on me anymore, please. It's no longer supported, so it's annotation processor or capt for Kotlin. So I mentioned Room is basically backed by an annotation processor, which is very convenient. It generates code for us. It also validates a lot of stuff, so it makes sure that the things that you define in code actually make sense, actually work at runtime, because otherwise you'll end up in the same situation as that other persistence frameworks trying to solve. You make some typo in your SQL statement, and at runtime it blows up. So this is pretty great about Room. Room basically consists of three ingredients that you need to set up. One are your entities. The first is your entities, which is basically the objects that you want to store in the database. Secondly, you have your data access objects, which control how you interact with the data. So how do you get the data from the database? What do you want to insert? What kind of objects you want to get back from the database? And to tie this all together, we have the Room database, which is the managed SQLite that Room will use to store all of these objects in. And so I will walk you through these three components. First, take a look at a simple entity. Well, entity might sound fancy, but basically just a Java class, just an object. You annotate it with this entity annotation. And once you do that, Room knows that this is something that you want to store in a database, and will also assign a table name to this entity. So this particular entity will map onto the user table in the database. And this is because by default the entity annotation will map onto the class name of this user, of this object. And you can also change the table name if you like to, though it's not very convenient if you do, because then you have this extra translation step where you have your query. You have to figure out what table does this entity map on, and then you basically need to do an extra translation. If you keep this the same, then it's pretty simple. You just say select my users from the user table. Another thing that an entity always needs is a primary key, because you need some kind of identifier in the database to know what kind of thing you are storing. And if this is a number, then Room can auto-generate the number for you. And by adding this auto-generate parameter, then you're telling Room that if this ID is either null or 0, then Room will go out and say, hey, well, this looks like a new object that you want to store. Let's generate an ID. But oftentimes your IDs are not numbers. So Room allows you to make this a string. No problem. But if you do this and then hit compile, Room will also greet you with this nice error saying, well, this is a primary key, it's annotated with auto-generate, and I basically have no idea how to generate a string for you. Which is fine. It's also an example of how Room validates the schema in this case. So it validates if it actually can store this. So this is not a runtime error, but a compile time error. So pretty convenient. So take off the auto generation in this case. End up with this. We have primary key. Hit compile again. Oh, another error. You must annotate the primary key with non-null. And it also says that SQLite considers this a bug. What it's basically telling you that old versions of SQLite allowed you to insert a primary key that was null, which doesn't make any sense, because how do you figure out what kind of object you want to store if this key is null? So it requires you to have a non-null primary key. So we go ahead and also add this non-null annotation. And once you annotate with non-null, Room will make sure that at the database level, it's impossible to insert any nulls. If you try to insert a null, you get an error. So this non-null also directly maps onto the database schema. So in this case, we made our ID non-null, all fine. But now we basically need a constructor to make sure it's never null. If you just keep it a field, then Android Studio would probably yell at you and say, well, this should never be null. So we add a constructor to make sure that we can pass in the ID. But we also want to store new objects. So I've added another constructor that generates some random ID. And now we run into a little bit of a problem, because Room's kind of confused. Says, whoa, I have no idea what constructor I should use when I construct this object for you. So there's another annotation that you use. It's called ignore. And you basically say, well, ignore all other constructors. And therefore, Room will pick this. It's a little bit of counterintuitive, maybe, but you basically ignore everything that Room shouldn't use. This might have changed in the latest beta, but I don't think so in this case. But I have another example. So yeah, now we have our entity. It's kind of like a Frankenstein between mutable, immutable properties. So let's change that. Yeah. quite a bit more code already. Also realizing that a user without a first name is kind of silly, so make that non-null also. And this will somewhat be our final entity. So this is like our basic POJO. Doesn't have equals or hash code yet. So yeah, but Room can happily store this and retrieve this from the database. For those of you using Kotlin, you probably feel where this is going. If you have a data class in Kotlin, Room will also store this for you. So this is basically the same, also actually more functional than this previous example. A data class also gives you hash code equals, so that's pretty nice. And again, we annotate this with entity. It maps onto the user table. We just give it a default ID if it's not supplied. And you might also notice, which might not be a big surprise if you're known with Kotlin, that there's no non-null anymore here, because in Kotlin this is in the type system. So in Kotlin we know that this last name, because it's an optional string, might be null, and the rest of these things might not are not null. So yeah. Is everybody using Kotlin already, or? Well, a fair amount of you. Okay, that's cool. So next code samples will be Kotlin. Should be fine if you're only used to Java, so nothing too fancy. But so yeah, this is what Room can store if you do Kotlin. So there are some extra options on that entity annotation as well. Like I mentioned, you have your table name. You can change it. If you have a composite primary key, you can also specify this in the entity annotation. So this consists of multiple fields in this case. Indices you are able to supply your indices as well. You can do all kind of variations. So you have an index on a single field, multiple fields, unique indices. Yeah, basically everything that SQLite supports. Another way to specify these indices is by using the column annotation, column info. You just annotate a property in this case and set that you want it to have indexed. And there are some couple of other advanced properties you can set on this column info, like the type infinity and the collation. And you can also, again, rename the column, which is, yeah, sometimes you need to, when you need to map to an exact existing schema or something like that, but by default, the default should be all right. Okay, so this should be pretty simple. So to sum up, entity classes are basically normal Java classes. You annotate them with entity. They must have a non-null primary key. And you can highly control all the representation in the database schema by using annotations. So once we have, this is something that I didn't quite realize until I was looking into the documentation. In the documentation, it's kind of, I'd say, a little bit confusing that sometimes they talk about entities and sometimes they talk about POJOs. And it's not really explicit. But Room, everything that Room needs to store in a table is basically an entity. So an entity has a mapping to a table. While a POJO is basically any Java or Kotlin object that you can map a result onto. So this comes in play when you're working with data access objects. So we see an example of that soon. But when you're reading the Room documentation, you'll see they use POJO and entity sometimes in different places, and well, can be surprising. So I mentioned data access objects. Data access objects are basically, or DAOs, are basically the ways how you interact with this data. So you define methods of how you want to work with your entities. And Room will actually create implementations of your interface or abstract class. And you can have one or many of those classes in the data for your Room database. So if you have like a huge data model, or you have separate kinds of business logic, you can split them up in multiple data access objects. And this is an example of a simple, simple. It has a lot of methods, but it's an example of a data access object. You annotate it with the DAO annotation, and then you just have methods, abstract methods, or interface methods in this case, where you say what you want to get out of this database. And then you annotate these methods with, in this case, query, which contains a literal SQLite query. And what's nice about this is that this query will be checked by Room as well at compile time. So if you make a typo here, then it will give you a compile error. And if it doesn't know how to convert, in this case, something from the user table to some other object, it will also tell you. If you're using Java code, Android Studio will even autocomplete your tables and properties and that kind of stuff. On Kotlin, not so much, but I guess that's coming. So yeah, here are a couple of examples where just do a select for a single user, map it onto a user, and again, Room will then generate this implementation for you. Same for all users, we just return a list of things. We can also just a single column. So if I want to get a list of all first names in my database, we just specify that we want a list of strings because Room knows how to map back the single column onto a string. Oftentimes you want to have some kind of query parameter passed into the query, and Room also supports this just by having a method parameter, and you map that onto the query using this binding annotation. So I've called this parameter fn and fn here, so to point out that these are the same things. And it all feels very natural, and Room just gets this basically. What's interesting, that query is not really limited to selects. You can also do deletes, so you can basically do any database operation that returns some kind of result. So you can also do a delete. And in this last example, we basically are renaming the first name to first and the last name to last, and map it onto a POJO in this case, which returns us a list of persons. And the reason why I need to rename this is because the person POJO has a first and a last property, and not first name, last name. So, but this shows that this is just a simple object. This is not an entity. It's not annotated with entity. So you can query anything out of a table and map it on an arbitrary object. This also means that you can do complex joins if you want to be that way. I don't personally like joins that much, but you can do this. The only requirement is that Room needs to know how to convert it and needs to be able to map the column names. Well, insertion is kind of the same thing. For insertion, you can also specify what happens if this object already exists in the database. So by default, it will abort, will give you an error. But you can also say, well, just replace the whole thing. You can insert a list of things, and if you use this syntax, then it will also make sure that all of the users will be inserted in one transaction. And you can also combine this with different types of entities to have all these entities be inserted in the same transaction as well. And depending on the return type, you can opt in to get the row IDs back. Probably not that useful if you're using string primary keys, but yeah, the option is there. Well, delete is not that exciting either. Just annotate with delete and pass in the things that you want to delete from your database. In this case, you do need to make sure that this has a primary key, obviously, otherwise you can't delete it. And again, this thing will run in a single transaction. Update, this is getting boring. We'll match the user primary key to update the whole object. So this is pretty interesting because now we can sort of work with our data model to do things that Room by default cannot store. So I mentioned we cannot store entity relationships. But what if I have this object where I have a user with a list of books, assuming books is also entities? Well, I can still model this. I can still have a list of books here. I just need to tell Room to ignore that field because we're not actually having this property on the table. And then I can supply like a default constructor that doesn't have these books set or just has an empty list. And then again, I need to make sure that Room ignores the primary constructor in this case. And once I do this, I can create an abstract data access object, which just has some protected methods because I don't actually want to use that as my API. I want to have it protected in this case. So I can insert a single user and can insert a list of books. And then I can implement a method that just calls these methods, insert books, insert single user. And yeah, that's pretty great, I think. And what's even better is that I can make sure that this runs in a single transaction by annotating this with a transaction. So I'm now modeling my business logic, more or less, in my data access object. Room will just generate all the stuff that's abstract and will actually override this function to make sure it runs in a transaction. And because it's overriding this object, you make sure, if you're using Kotlin, that this function is also open. Otherwise, it can't really extend it because it will be final, this method. OK, now, so I have my entities. I have my data access objects. Now I need to tie this together with the database. So the database is another abstract class that you write. It extends from room database. And on the database annotation, you specify the list of entities that should be in this database. So it's basically, you're defining all the tables that are going to be there. You're also specifying a version, and that is important for migration and upgrades later. And then on this class, you just have abstract functions for your data access objects. So I only have one in this example, but it could be multiple. And then you need to use the room builder to make sure that at runtime you get a single object of this database. And it's important that you have like a singleton kind of object for this, because there should be only one connection to the database, which you can then interact with from multiple threads as you need. So in this case, I opted for just like a getInstance method, but could be you can just inject this or use your favorite method to make this a singleton. But as long as it's a singleton in your application. So we finally arrived at the point where we can query our database. So let's get our database singleton. Let's get our user DAO, and then let's query some users. And all should be good, right? Nope, it's not. If you try this in an actual app, you'll be greeted with this nice exception where Room is very helpful and tells you, yeah, you cannot access this database on the main thread since it may potentially lock the UI for a long period of time. And this is true because we're doing I/O basically. We're locking the main thread potentially, and yeah, Room is generally being helpful here, saying nope, you can't do this because. Yeah, it was actually never OK to do this, right? But we probably all cheated sometimes and did it anyway. So yeah, Room helps you to do the right thing in that sense. The bad news is that Room doesn't really give you any means to not run it on the main thread for insert, deletes, and updates. So if you're doing that kind of operation, you have to find your own mechanism to do that. So it's either async task, it's an executor, ArcJava, maybe Kotlin coroutine if you want to get fancy. So yeah, there's nothing in Room yet to help you there. That's kind of unfortunate. For testing, there's this exemption that you can make on when you pass in allow main thread queries on the database builder, but that's only for testing. So promise you only use this for testing, please. For queries, there is something built in. And it's not only async queries, it's also observable queries, which is kind of nice. So you can basically subscribe to a query and have that query give you new results as they come in. So there are two methods to do this. You can either use the architecture components live data object, or you can use ArcJava 2 if you're already using that. I would recommend to try the lifecycle stuff because that's basically tied to the lifecycle of your activity or of your application, and you're also making sure that you not querying the database when your app is not active. Using this is again pretty simple. You just have your data access object return not a list of user, but just a live data of user. Or if you're using ArcJava, you just return a flowable. And if a new user would be inserted in this table, then the live data will be updated automatically, or the flowable will just emit a new value. It's pretty nice. If you're using ArcJava, you can actually also use the maybe and single types here. And maybe and single will be one-shots, of course, but yeah, that's also supported. And using this is pretty simple. If you're using live data, you just observe it in your own create, have some method doing whatever you want with the list of users, and yeah, it will basically give you a result of users once they are available. So this is pretty convenient. Okay, so up to now I have like very simple entities, not much going on. Oftentimes you have like data types in your entities that you do not directly map on SQLite basically. So SQLite only has simple types like numbers and strings and binary. A type converter gives you the option to convert a particular object or type into a SQLite value or a column. And nice about this type converter is that you can scope them on various levels. So you can be very precise and say, for this entity only, or for this field in this entity only, I want to use a particular type converter, and in all other places I want to use something else. And this is very granular up to the entire database. Unfortunately, there are no default type converters for dates and enums and that kind of things that I would say were pretty typical. So you have to write this yourself. Well, this is an example of a converter. When you're writing Kotlin, you make sure that this is a static method. It's just an object with static methods, basically. And the conversion is pretty simple. So you convert a date to a long, or a long to a date. That's easy. And then we have various options to use this thing. So like I mentioned, you can say, well, only for this field we'll use our class of type converters on this birthday field. It probably makes more sense to do this on the whole entity if you have multiple dates. It probably makes even more sense to do this on your database to make sure that all your dates are converted the same way across the database. But you can just tweak this and you can override in particular places when you want to do this. What's also nice is that you can use this on your data access object. So you don't need to do the mental shift of, oh, this field's actually stored as a long, so I need to query as a long type of data. No, you just pass in the date. Room will figure this out and say, oh, this is a date in your model. I know how to convert a date and query this accordingly. There are also times where you have a more complex object. In this case, I have an address, which I tag onto a user. Well, I could use an entity type converter here to just maybe string all these fields together and store it in one column in one string. But Room has a better option for this. It has the embedded annotation. And what that basically does is it flattens down the whole object onto the table, which is convenient because now our user table will have a street, house number, column 2, which means that you can now query on all users, in this case a city, or with a certain house number, if you into that thing. I don't know, sure it's that useful. But all users in a particular city might be useful. And what's also cool about it is that if this address or some other object also has an embedded annotation, it just drills down basically. So all these columns of all the embedded objects will then be flattened down onto the user table. I think that's pretty powerful. Okay, let's talk a little bit about migrating data. Because as your app will evolve, you're bound to add some more properties to your entities, add some more entities, well, that kind of thing. Your database will basically change. And so you need to migrate your database to that new world. And migrations is the way how Room does this. It's basically tied to the database version that you supply in the annotation. And every time you make a change to your entities, you basically bump the database version. It's pretty similar if you're now writing your own SQL data. You just have, by default, you have the SQL Open helper where you do the same thing. Room wraps this in the database. And you can supply migrations from any version to any other version. And Room will figure out which ones to run once it's creating or upgrading your database. So it doesn't necessarily need to be a migration from version 1 to version 2. It can be from version 1 to version 5, and you have others from 2 to 4 or whatever. By default, if a migration is missing, it will crash your app. actually, I think that's a good thing because it allows you to revert your mistakes and not have deleted all of your user data. What this was doing before. If a migration was missing, it said, "Oh, missing migration. Let's destroy all data." I wasn't convinced that was the best solution, and unfortunately they changed it. But it will still crash. So if you're missing a migration, it will crash. You'll panic. You'll update your app, and hopefully will be on your way then. So writing a migration is pretty simple. You just have this migration object from version to version, and then you're basically on your own. You need to write all the SQL yourself. So you need to make sure that the tables are in the correct state after the migration. And not only the tables, also indices and all other stuff that the room might generate for you. Which is kind of, I don't know. In other places, Room will help you a lot, will validate all kinds of stuff. And now you're migrating your data and so, well, good luck. Let's migrate it. And if it doesn't work, I'll just throw in an error. Okay, so I think they're probably going to generate these things eventually, but yeah. Adding the migrations, you do that by adding them to the database builder. And like I mentioned, you can add multiple migrations and Room will just figure out what to run. This is also where these schemas come in. So Room will generate a schema of your database when you compile your app. And over time, if you're changing the database version, it will generate something like 1.json, 2.json in that directory. And that file will also contain the exact statements that Room is using to create your tables. So you're basically going to peek into that file when writing your migrations to verify that the stuff that you're actually migrating matches what Room is expecting. And there's also support for testing these migrations. That's probably your only option because a migration crash will always be at runtime because the tooling doesn't help you in this case. And if you are using your database just as a cache, you don't really care about migrations at all, then you can still fall back to the destructive migration by adding this option to the Room database builder. Another issue, or no, that's not quite. What's great about databases is that they can produce a huge result sets, right? So that's actually pretty nice. What's challenging is how you handle that in your app. Because I showed you this list of users. What if I have thousands of users? It might be just a performance issue waiting to happen with a lot of users in memory. Well, we used to solve this by using a cursor and a cursor adapter, which would be fairly smart in paginating this data and making sure that you're not loading the entire result set in memory. However, it turns out that these cursors have their problems. And there's this blog post from Google, which basically argues against these cursors in the database and proposes another solution, which is paging. Paging is another architecture component. I have not enough time to actually show you all of paging, but what's important is that Room supports paging here by generating implementations that a page list can use. So the basic idea of paging is that you have a list, and that list does not contain all the items that you have in your database, but it will be smart about it and fetch the chunks as they are needed. So going from this to a page list is as easy as just specifying the return type of a tile as a tiled data source of user. And then you can feed that one into the paging components, basically. And this is a one-shot kind of query. It won't really be observable. If you need that, then you also have another variant, which is a live page list provider of int and user. Int is in this case because it's querying the chunk numbers. That's basically it. And underneath it will use limit and offset to make sure that you query your database in a smart way. So these are basically the ingredients that you need for paging, and then there's some other plumbing that you need to do to have the paging components work. But if you have this, then it will make sure that once this table updates, will be smart about updating your page list as well. So there's a tight integration here. Oh, there's more. More stuff that just want to mention, and not to go deep, very deep into, foreign key support. Room supports foreign keys, and if you're familiar with databases, this is useful for doing things like cascading deletes. So if I have my list of books and a user, once I delete the user, I probably want to also delete that relationship with the books. So I can do this cascading. Also integrity checks. If I insert a book which belongs to a user and the user does not exist, the insert should fail basically. And there are annotations to control this. Actually, one annotation to support this. Yeah, so that's pretty cool. What's also pretty nice is that Room doesn't directly build upon the Platform SQLite implementation, but they also introduced a sort of abstraction which allows other SQLite compatible implementation to be plugged in. So this opens the door not only for Room but also other persistence frameworks to use, for example, SQL Cipher or what have you. If you have some kind of crazy optimized SQLite version that you want to use, a binary, then you can write this implementation for it and plug it into Room. So that's pretty nice. And I mentioned that Room is not able to do these entity relationships. But browsing to the docs, there is an annotation called relation. And what relation does is actually fetching the relationship from the database eagerly, but you cannot use it on an entity. So you can also use it on a POJO. It's kind of, I don't know. It's kind of something that's probably in flux and not really fleshed out yet. But if you need that kind of functionality, it's still there. But again, it only works on POJO, so you can't still not expect to store your entire object hierarchy into the database. And then there's some testing support, which is actually pretty well documented in the Room documentations. So summing up, we now have an official persistence library for Android, which is a little bit late, but nice that we have it now. It's actually very capable. It has nice Kotlin support. There's no need, for example, to have default constructors which take no arguments, that kind of stuff. There's tight integration with other architecture components, so you can integrate it with live data and paging. And there's also integration with ArcJava 2, which is nice if you're already using this. And if you want to learn more, I recommend to go to the documentation of the main Room documentation. There seems to be some mismatch still between Java docs and documentation. So there might be some stuff in the Java doc that is not in the documentation yet. So it's useful to also look at the Java docs. For example, that relationship annotation is relation annotation is in there, but it's not in the docs. So yeah, I recommend you to check that out. And that was basically all I had about Room. So thank you very much.